Alright, today we're talking about simplifying expressions using the GCF. GCF means greatest common factor. Greatest common factor. Alright, so first off we're going to prime factorize. Alright, prime factorize. Now how do we prime factorize? If you guys don't remember, there's two ways. There's inverse division and there's a factor tree. I'm going to show you guys both of these. Alright, so let's start off with the factor tree. Well, how do I get, what two numbers can I multiply to get 144? I can multiply 12 times 12. Now I can break up. Now if I find any prime numbers, I'm going to circle those. 12 is not prime, so I'm going to keep going. Alright, but I can break up 12, and I can break that up to 6 times 2. 2 is prime, so I'm going to circle it. 6 is equal to 2 times 3. 3 is prime, 2 is prime, so I'm going to circle those as well. Now don't forget our prime numbers are 2, 3, 5, 7, 11, 13. If you guys can remember those, you're off to a great start. Now here, 12, I have to go back up here and finish it. I could go 4 times 3. I don't have to use 6 times 2. It works out to be the same thing either way. I get 2, 2. So I'm going to prime factorize, and that is 2, and I multiply 2 4 times 3 to the second power. And if I did 4 times 2 to the fourth power times 3 to the second power, I would get 144. The other way we can solve this is called inverse division. I don't know if you've seen this before, but you can divide like that. And what I do is I start with my lowest prime number, so 2. Can I this number to be divided by 2? It can. And I get 90. I can divide this number also by 2, and I get 45. Alright, 2, it doesn't work, so I'm done with 2's. 3's, it can divide by 3. If you remember the quick way to figuring out if a number can be divided by 3, add the 2 digits to the number. 4 plus 5 is 9. You can divide 9 by 3, so you can divide 45 by 3. Alright, that is 15. I can divide that by 3 as well. That is 5, and that is a prime number, so that means I'm done. And this is what I'm going to do. So that's 2 to the second power times 3 to the second power times 5. Either of these ways work for me. I don't care whichever way you like more. Please do. That's how you prime factorize. The way I would find the GCF is I would see what numbers do they have in common, and that would be my greatest common factor. So here, this one has 2 2's. This one has 4 2's, so they have 2 2's in common. This one has 2 3's, this one has 2 3's, so they have 2 3's in common. This one has no 5, so that's my greatest common factor. 4 times 9 equals 36 would be my greatest common factor. That's how we find the greatest common factor and how we prime factorize. We're going to use that as we do these problems. The nice thing about this is it's a lot easier when the numbers are already divided out. This is how I do it when I have variables, alright? Variables, I need to find for each term, each common term, I need to find what they have in common. So here, between 12 and 8, what's my greatest common factor? Well, they have 2 in common, they have 4 in common, but they don't have anything else in common. So 4 is my common factor. Now, how many A's do they have in common? This is always the lesser one, alright? This has 4 A's, this has 3 A's. 3 is lesser than 4, alright? So it'll be a to the third power. B's, this has 1 B, that has 7 B's, so just 1 B. C, 3, 0, so it has just 0 C's in common. So my greatest common factor is that right there. 4, because of the 12 and 8, a to the third power, and B. Finally, greatest common factor here, alright, 15 and 20. Well, 5 is my greatest common factor between 15 and 20. Let's look at the A's. I'm looking for that lesser value, 6 and 4, so it's 4. B, this just has 1, that has 9, so just 1. C, they both have 3's, so 3 works. That's my greatest common factor. Here I'm going to factor each polynomial. The way I factor each polynomial is I find the greatest common factor, and then I write in parentheses what's left, kind of like the distributive property. So here in this one, they each have a 4. See, 8 I can divide by 4, 4 I can divide by 4, and 4 I can divide by 4. X, I take my smallest exponent, which is 2. Now if I take away a 4, that leaves me with a 2 left here. And if I take away 2 x's, that leaves me with no x's. So 2 is my factor here. If I take away a 4, that leaves me with 1. If I take away 2 x's, that leaves me with only 2 x's. And here if I take away a 4, this is a minus sign. Alright, that leaves me with 1. And if I take away 2 x's, that leaves me with 1x. So that's how I factor them out. Here, let's look at this one. My common number is 12. I have 3 y's and I have 2 z's in common. 12's, y's, and z's. If I take away 12 divided by 12 is 1. Y to the third. I take away 3 y's, that leaves me with 0 y's. And it leaves me with 6 z's when I take away 2. Minus 1. If I take away 3 y's, that leaves me with 2 y's and 0 z's. You don't have to have these 1's here. So if you take away these 1's, that's still okay. Remember, if we don't have anything coefficient in front of the variable, then it's like there's a 1 there anyways. Last one. We need to simplify this. Alright, so this is what I want to do. I'm going to factor out my top number. Alright, so I have a 6 in common. I can divide 72 divided by 6. So I have that in common. So 6g, they both have at least 1g. That leaves me with 1 minus 72 divided by 6 is 12. And I have 3g's left over. Here, I can just keep this the same. G squared h. Now, here I can cancel. 6, I can divide them both by 6. That makes it 2. This g can cancel out with this 2 and leave just 1 left over. I can only cancel out what's on the outside of the parentheses. That's all I can cancel out. That leaves me with 1 minus 12g to the third power over 2gh. And you can see here that I cannot cancel anything else out. Alright? There's nothing else that all 3 terms have in common. So I am done. This is pretty new, so I expect you guys have the questions. Again, please feel free to ask. I'll see you guys later.